Scroll through any social feed right now, and you will see two things: headlines about mass tech layoffs and a flood of gurus selling $99 courses on how to become a prompt engineer. People are terrified of losing their livelihoods, and they are reacting to that fear by trying to master the chat box. They are optimizing for the exact tasks that the machines are natively built to automate. Memorizing a list of prompt templates gives you an immediate productivity spike, but every time you type an instruction into the interface, you are feeding the system the exact data it needs to improve its own intent recognition. You are teaching the software how to bypass you. When your primary professional skill is typing natural language into a user interface, you become a commoditized operator. You enter a race to zero margins, competing against the speed of the machine itself. The market is currently operating under a financial illusion. The low monthly subscription fees you pay for artificial intelligence are an artificial subsidy. Big tech companies are burning billions of dollars in cash to get users hooked, masking the actual cost of the infrastructure. Look at OpenAI CEO Sam Altman. He estimates that to externalize the logical processing power of just one single human brain, it requires 4 dedicated graphics processing units. Scale that requirement across the global workforce. We do not have the physical silicon to build those processors, nor the electrical grid capacity to power them. The thermodynamics alone make cheap, ubiquitous personal AI an impossibility under current hardware architectures. This leads to an inevitable market correction, the Inference Tax. Eventually, the initial adoption subsidies will disappear, and the massive, true cost of computing power will be passed directly down to the consumer and the enterprise. When the subsidy ends, the profit margin on a human middleman collapses. For firms already struggling with rising compute costs, these shallow operator roles become an immediate target for downsizing, as the business case for human-in-the-loop typing fails. Money is only the first fracture. Long before the financial subsidies run out, this system will collide with modern law. We operate under a legal framework built on human intent. We distinguish a tragic accident from a crime based on what a person meant to do. A machine has no intent. When a model makes a catastrophic error, the law cannot sue the code, leaving corporations with a massive liability vacuum. Consider the recent Amazon network outage. A portion of their regional infrastructure went dark for 10 hours because an unverified segment of AI-generated code was deployed directly into production. The immediate corporate response was telling. Amazon had to go back and rehire the human quality assurance engineers they had previously laid off, bringing them back specifically to read the machine's code line by line. The economy does not need faster typists. It needs highly paid human validators. Companies are desperate for people who can catch invisible, silent errors before a flawed output triggers a multi-million-dollar lawsuit. Securing a position on the surviving side of this economy requires stepping away from the chat window. You must stop looking at the interface and start looking at the container. The modern trajectory of this technology started here, with the 2017 publication of the Attention is All You Need paper by researchers at Google Brain. This document introduced the transformer architecture. This visualization shows what is actually happening beneath the text prompt. The software is not thinking, it is executing irreducible linear algebra. It converts language into high-dimensional numerical vectors and calculates statistical probability. Because it is a stochastic process predicting patterns, it is mathematically guaranteed to generate plausible, confident-sounding errors. It strings together statistically likely numbers that translate into false information in the real world. If you lack the mathematical foundation to trace how those vectors interact, you cannot audit the machine's logic. And if you cannot prove why a system failed, you are a liability to an organization, not an asset. We are watching a structural split in the labor market. On one side are the operators, whose value is tied to subsidized tools. On the other are the logic directors, the architects who design, audit, and own the risk of the systems. Crossing that divide requires enduring intense cognitive friction. Transitioning from a passive user to a structural architect involves painful neurological rewiring. It is a multi-year commitment to deep study, completely divorced from weekend crash courses. The first phase of this transition isolates the deep mathematics. You have to internalize linear algebra and probability to understand exactly how the software processes inputs as numbers. From there, you apply statistical modeling to evaluate risk and make decisions under uncertainty. Finally, you learn programming mechanics to actually architect and scale the automated workflows. Recruiters are already adapting to this new standard. While a university degree might provide the mathematical theory, the hiring signal is shifting toward proof of work. Recruiters are increasingly looking past formal credentials in favor of tangible, shipped projects that demonstrate you can apply high-level logic to real-world deployment. Stop passively scrolling through AI tools waiting for the bubble to burst. Pick one repetitive workflow in your specific industry. Automate it. Understand the exact math driving that automation and publish your results. In an economy drowning in generated content, a defensible career moat is built on mathematically backed judgment.